So the ray on the x-axis is called the initial side. Okay, the other ray, so when I say other ray, I'm talking about this one that's kind of off in space. The other ray is called the terminal side. Right? Terminal end, terminal illness, you're going to die. So it's the end of the angle. So right here, initial side. Right here, terminal side. Okay? Angles can go either way. If the angle goes this way, it's positive direction. So counterclockwise is positive direction. If I go the opposite direction, that's negative. Okay? We'll do all sorts of stuff with that. It's crazy. So counterclockwise results in positive. Clockwise is negative. So if we look at this little circle over here, right? It's put into the 4 quadrants. Where's quadrant 1? Upper right, upper left, lower whatever. Upper right, okay? It's a good idea to put quadrant 1 on there. Roman numerals. You can write 1, 2, I don't really care. Okay, where's 2? Upper left. I'm going Roman numerals. What up? Right in that cart right there. You got to turn that little dial middle right, then grab one. 3, so which way does it go? Clockwise or counterclockwise according? Counter, okay? And then 4 is IV. If I think about the signs of an ordered pair up here, what are the signs? Like positive or negative? Positive, positive. So plus, plus. How about quadrant 2? Minus, plus. Quadrant 3? Minus, minus. Quadrant 4? Plus, minus. All that stuff will just kind of help orient your brain and help you kind of figure out what the heck's going on. Eventually that'll be like, you'll know it cold. You won't even have to think about it, right? But for now, when you're getting used to this stuff again, you may have to think about it. Try to draw 65 on your own. I'm going to freeze the screen. You can see if you're right. So when you think about drawing it, you got to make it look like this up here, right? So you got to have the initial side, make it thick and dark so I can tell. And you got to have this little arrow going, right? The arrow points to the terminal side. So when you draw 65, go for it. And we're not doing this to be like perfect, okay? So the middle is 45. The straight up and down is 90. So you don't have to be all psycho about drawing it, right? It's going to be okay. That's too small. Do you have something that look like that? Good, you got your first math problem right. Good job. High fives all around, okay? So if I go all the way around, I get to what? 360, right? A circle is 360. So if I want to go to 320, am I in the middle of this quadrant? More or less in the middle? Which one? More or less in the middle? So how do you know for sure, right? Because it gets weird when you're subtracting, right? I fully get that. So if we go 360 minus 320, what do we get? 40. So if this is 45, then 40 is going to be a little less, right? Okay. So initial side here, and then it goes all the way around like that. So you can always do math to figure it out, because if you draw that on the wrong side of that quadrant, I'll take points off. I should, right? Because it's not right.
That makes sense.
Okay? So 415, what's going on with that? So we go 415, what should I subtract? 360. What do I get? Do it in your head. You got it. What? 55. Okay, I got to move that. Handy iPad. You should get an iPad in college. It's super handy to take notes because you can record your professor in college And if you take notes, like every once in a while, it'll happen in here, right? I'll speak too fast or you don't get the example and you're just like hanging on by your fingernails, like I totally don't get it. And if you have an iPad, you can record the lecture and then you can just stop and listen instead of frantically writing notes down. And you can go back. You don't have to listen to the whole lecture, right? You just listen to that single example and then you can listen again and be like, oh, I get it now, right? Because you can slow it. You can listen to it like 3-4 times. You can do the same thing with my videos that I post as well, right? Going back to study for a test, there'll be one section that's tough for you, right? That you're like, I don't really get that one. You can go back and listen to that video multiple times. Also on here, the woman, Gina Wilson, who made this curriculum, all of her videos are on there as well. If you like her videos better, you won't, then you can listen to those. I don't care, right? Totally fine. You won't hurt my feelings. Okay, 415, less or more than the middle of quadrant 1? More. So I'm going to draw it just a little bit more. Here's my initial side. So you see why the little circle arrow thing's important, right? So I start towards the center and it goes all the way around one time like that. Okay? So these get weird when you get negatives on here, right? So if I go this way, I'm going negative direction, right? If I stopped right here, what am I at? Negative 180. So what should I do with negative 180 and negative 140 to figure out where that goes? Subtract. What do I get? 40. So is it right in the middle? Less or more? Less. Okay? So the handy thing with the iPad is I can go like that and then I can just move my angle wherever I want, right? Because it makes a straight line for me. And then you draw your arrow going back this way. So make sure you have initial side and terminal side when you draw those. Do number 6 on your own. Okay, I'll freeze the screen. You can double check, see if you got your second math problem of the year correct. Huh? When's your birthday? Ooh, that's a long way to wait. Christmas. I'll get. It's so nice. I started teaching with this thing like 3 years ago, and one time I dropped it in my bathtub. I was watching the Masters golf tournament, and I saw them playing the Masters below the water, and I was like, ooh, and I grabbed it like in a split second, but it was horrifying, right? And I went and bought one immediately. Like as soon as Apple Store opened, I was in there and I bought another one because I have to have it now. I have no choice. If I didn't have it, it'd make me cry. Oh, it's the best. Yeah. Well, the cool thing about college too is you can copy things from slides into your iPad, right? You can have professors oftentimes will give you blank notes. Like I have a kid in ALTS 2 who has my blank notes above and he writes notes below, right? Or I'll have the homework above and he'll write the notes below or do his homework below. So it's just super handy. I should get paid by Apple, but How many people got that right? Raise your hand. Okay. Good. Nice. All right. Radians. Anyone remember how that works? You studied the unit circle last year. One revolution around the unit circle is how many radians? 2. Okay. So if we think about this circle up here, actually we'll just draw a new one. So draw a new circle. That'll be fun for you. I have the iPad, so it'll make it perfect.
How did you do that, bro?
It snaps to a circle perfect, so don't think I'm some magic person drawing circles. Okay, so if I go, this was 0 degrees, right? This is 180 degrees. This is pi radians right there. So if it's pi on the left, what's this one? Half a pi. What do you call it? Pi over 2. Good. Yes. Pi over 2. Half pi.
Half pi.
So then I like to count these around, especially once we get to that unit circle, memorizing again. It's much easier in my brain if I just count around, right? So I think of it like this. I count 1 pi over 2. This one's 2 pi over 2. which reduces to what? Just pi, right? So what's this one? 3 pi over 2. So we can write 3 pi over 2 on the bottom. And then 0 degrees is 2 pi. Okay? So halfway around the unit circle is pi. So the math nerd who figured that out, you know pi is 3.14? So the way they figured that out is they took this radius, right, from the center of the circle to the edge, and they got something that's like spaghetti, cooked spaghetti, right? And they took it and they stretched it around once, twice, 3 times, and they were a little bit short. So that 0.14 pi is that little portion to get to the negative x-axis, okay? So 1 radius, 2 radius, 3 radius, 0.14 is this part right here, okay? Just so you know. Some teachers will get like literally cook spaghetti and bring it in and have you lay it around the unit circle. I will never do that, okay? I can just talk about it and we do it in like 2 seconds, right? And you get it. Okay, so 360 equals what? 2 pi. 180 equals what? Pi over, or just pi. I was about to go pi over 2. Okay. Now we are switching from radians to degrees. Okay? So we're doing conversion. So if it's in degrees, you can tell because it's got the little degree symbol right there, right? So if we switch to radians, so you look at these, I don't like these formulas just because it has the word radians, right? I like it without the word radians. But if I want radians, I have to have the pi on top, right? So I have to multiply this times pi over 180. If you have a graphing calculator, bust it out. Right? If you don't have a graphing calculator yet, then this is where you begin to suffer. If you need to borrow one, you can leave your phone up here and grab a calculator out of this bottom drawer. If you don't have a calculator and you're not borrowing one, you're not smart. So you should borrow one, okay? Bottom drawer, I have 3 graphing calculators to loan. Just grab your phone if you haven't. Did you already have your phone up here? Grab your phone. It's how I get the calculator back. Yeah. Keen, I got your computer, so you're good. Grab your phone, put it up on the desk, and grab a calculator. I already have your phone. Yeah, you're good. Bottom drawer. Bottom drawer. I have 4 of them below that paper. There you go. Last one. It's a special one. A kid painted that for me. See the Evans? Yeah, grab that one. Okay. So in your graphing calculator, you're going to learn how to reduce 60 over 180. It's oh so handy. You can do it that way too. I'm just going to show you with the big numbers. 6 divided by 180. Uh-oh, freak out. No, I don't want, I can't see it. That's not cool. Let's see if I can hit it. No. Let's see. That's annoying. Okay, 60 divided by 180. Oops. Okay, now we're good. And we hit math, middle left, right below the green button, middle left, and then enter twice. So if you have always sucked at reducing fractions, you have a calculator now. You don't suck anymore. Okay? It's nice. Math enter is your friend. It'll switch from decimal to fractions, unless it's some weird improper thing, right? And it goes back and forth, right? It'll reduce fractions. It'll go from fraction to decimal and decimal to fraction. Okay? Math enter. So what's my answer to this one right here? What's the answer? Pi over 3. Where's that on the unit circle? What quadrant? First one. It's at what degree? 60, because it says it right there, right? Yeah, good job. It was a trick question, right? And you paid attention. You're like, duh, it's right there, dude. You do different colors when I do different colors. Like if I'll write little helpful hints on there and stuff. So what do I multiply this by? Pi over 180. Do it. Do it. Do it, do it, do it. I'm going to have all your names on cards soon enough here. And then I will call on you frequently. So if you freak out about getting called on, get over it. I'll call on you a bunch. And if you totally wig out, right, I help you to the correct answer. When I call on you, I'm never trying to humiliate you, right? I want to, and if you don't know the answer and I call on you, that learning in the moment is some of the most powerful learning you'll do, right? Because you are so focused because you're like, oh my God, I'm getting called on in front of 30 kids. That's scary, right? But I will help you through it so you have faith in me, right? Because I don't want to embarrass you. That's not the point. What'd you get? 8 pi over 9. You can write it just like that, okay? You could technically put the pi right over here next to the fraction bar, but write it like that is better. 8 pi over 9. Okay? Do 11 on your own. You can still do it in there. It's all good. You just write the negative up top. Okay, we good? Oh, I meant to freeze the screen. I forgot. Oops. Negative 23 pi over 18. Okay? So I'll ask this question a bunch in my class. Fist means I have no idea what the hell you're talking about. 5 means I totally get it. Fist of 5. Tell me. Show me. Right? Look around so you can see how many people have the 5s up. Right? 3, 4s, all good. Right? Now, if I ask that question and on the regular you have like 2 or 1 or fist up, what should you do? You should ask questions, right? Should you maybe come in for help as well? Yeah, that'd be good too, right? I'm here before and after school every single day. And Wednesday, not before school because we have access time. Okay? All right, we good on that one? Try number, I can't see it, 13 on your own. You're going the opposite direction. So instead of pi over 180, what is it? 180 over pi. 13. What happens to the pies? Sure do. So if you're going from radians 2 degrees, you know the pi's on the bottom because that's the only way the pi's cancel. Right? So if you logically think about it and you forget what the rule is, if you're going from radians to degrees, the pi's got to be on the bottom because that's the only way. Otherwise, you'd end up with pi squared and you'd be like, no, that doesn't make sense. Right? So even if you totally forgot and ended up with pi squared, you're like, no, knucklehead, I got to flip it. Okay? No big deal. Do you get that? 50 degrees? Okay, try 15 on your own. The number we should never say in a math class. It happens every year. I try to avoid it like the plague. You're doing fit. You'll see what the answer is. And then you'll be like, oh, I get it. Yeah, see? I try to avoid it always, and it always creeps up like it's not it, though. What's the other inappropriate number for math class? 420. 420.
What up?
Wah, wah. For all you dope smokers out there, that one's for you. And then stop smoking dope. It messes you up. Kills your motivation. Okay. Do 17. 17. We still got a lot to do, just so you know.
Are we doing this for the entire class?
You'll have plenty of work time as well. But the lessons, we do this page and 2 more. Okay? So 4 pages of notes. We won't do every problem. But if you get stuck, right, or you need more practice, there are always more practice problems on here. So if you're studying for a test, I'll have these answers posted. Now, when Gina makes these answers, because I didn't make the answers, she skipped some steps, so you just got to get over that, right? And if you need the steps, you can ask me and I'll help you. Okay, you're doing 17 on your own. Is that what you're doing? Yeah. Okay. We good? Negative 285? Right? Pretty easy? Okay. So, new topic. Related but new. We're talking about coterminal angles. So, what is a coterminal angle? It means like if we have 90 degrees and I go another revolution around, we want the angle to be in the same position on the unit circle. Does anyone know why it's called a unit circle?
It's a big circle.
Nope. It's a good guess. It's got some units on it, sure does. What's the radius? What's the radius of the unit circle? Oh yeah, see? People are like, I don't know. It's one. It's 1 unit. That's why it's called the unit circle. Isn't that a dumb reason? I think so. Okay, so coterminal angles. So when we get a shut it. When we get a coterminal angle, if we're in degrees, we're going to add or subtract 360. Sometimes the directions will say I want a positive and negative coterminal angle. So you have the angle that you're given. You'll either add or subtract 360. Sometimes that angle, like this one way up here, right? We went more than one time around the unit circle. So if I need a negative coterminal angle for 415, if I subtract 360, is it negative? Nope. What do I have to do? Subtract it again, subtract 720, right? So if you like skiing or skateboarding and you know what the revolutions are, right? What's 3 revolutions? Anyone know? 1080. Yeah. Okay. So you may have to subtract 360 multiple times or add 360 multiple times. Now, if we're talking about radians, what do you add and subtract? What's 1 revolution around the unit circle? 2 pi, right? So we're going to add and subtract 2 pi. It gets weird when we have fractions, but I have a good trick for you. But we're doing degrees first. Okay, so angles in standard position with the same terminal side are coterminal. Determine whether the 2 angles are coterminal. So what do I do with 305 to determine if negative 55 is coterminal? Subtract 360. Do that on your calculator. Tell me what you get. Do you get negative 55? So yes, that one works. When I subtract, I get that. So do number 20 on your own. Sure can. No. That one does not work, right? You subtract 360, you get negative 330. That is not negative 170, so that one does not work. Those 2 angles are not coterminal angles. Okay, so adding 2 pi like messes with kids like crazy, and it's the dumbest thing ever because it's not that hard. Okay, so if I want to add 2 pi, what do I have to do to that denominator? Multiply by, not 4, because I want 2 pi, right? So all I have to do is double the denominator. So if I go pi over 4 plus 8 pi over 4, I'm adding 2 pi because what's 8 divided by 4? 2. Okay? So I need to subtract it though on that problem, my bad. So what a great time to write a helpful hint, right? So I recommend you write the helpful hints in the same color for the entire school year. I know it won't happen because you'll forget that one pen. And if it were me in my own class, I would write the helpful hint in a color I found obnoxious. So I would write that helpful hint. In radians, I have to double the denominator because hot pink is not my jam. So double denominator. To add 2 pi, right? I don't know how to say that. You write it however the hell you want. I'll say to add 2 pi. So if I look over here, what do I multiply that by? What is 2 pi in halves? Double the denominator. 2 times 2 is 4. 4 pi over 2. So that's what I'm going to subtract. Oops. Okay. So if I subtract that, what do I get? 3 minus 4 is what? Negative 1 pi over 2. If I subtract it again, what do I get? What's negative 1 minus 4? Negative 5 pi over 2. Are those coterminal angles? Yes, because we can subtract multiple times. So this one's a yes. How about the first one? I didn't ever finish it. So we were subtracting. We would get what when we subtract that? 1 minus 8? Negative 7. Don't be scared to answer those questions. Right? Even if you get the wrong answer, just like trying and thinking, like we're trying to be active in this class. So when I ask a question, and I'll have all the names on cards eventually here. But for now, like you're always thinking about what that answer is. Right? So every single question I ask, you're trying to come up with the answer. And then you see if you're right or not. And you might want to write a little note down then if you're not right. Okay? 2 coterminal angles for, make that a little smaller. So 1 positive, 1 negative, what do we do? 150 plus 360. And then 150 minus 360. Right, so I will let you use your calculator for every single thing in here. Every single test, you can use your calculator. Some teachers are like, why do you let them? Like, that's crazy, right? Even if we'll do these crazy graphs next semester where like you get 2 vertical asymptotes, a horizontal asymptote, you'll get a little U in the middle and you'll get things that look like this and then there'll be a hole as well. So like the concept of the graph, like you have to prove every single aspect of the graph. So I don't give a crap if you see the picture on your calculator. Otherwise, it's such a pain in the ass because you have to plug in ordered pairs to figure out where all the parts of the graph go. And I just don't find that totally useful, right? Because you guys will make little mistakes plugging in the ordered pairs, and it's just not a good use of your time. What do I get on the left equation? 510. What do I get on the right equation? Negative 210. So you guys don't know me very well yet. If you gave me that answer, I would take points off. Why? No degree symbol. How many? So if that problem's worth 4 points, what's your guess of what I would take off? 2? How much of the problem did you get if you just forget the degree symbol? You got almost the entire problem, right? I only take a half point off. Okay? So I grade very fair, right? So like you understood like 85% of the problem, right? You're just a knucklehead and forgot the degree symbol. So if you know you're a knucklehead like that, I was in school, I would make that degree symbol in hot pink because then I'm more likely to remember it, right? Or red or whatever, okay? So that organized use of color to make that jump out at you. So when I go back and study these notes for a test, I'm like, don't forget the degree symbol. And I write mean notes to myself as well. I'd be like, hey, idiot, don't forget the degree symbol. And then I wouldn't forget it. Sometimes I still do, which is even more stupid. All right, try number 25 on your own. I'll write the answer. You can see if you're right. 1 positive, 1 negative. So remember, not on this one, but sometimes you have to add or subtract multiple times. 360 or 2 pi. So just get ready for that. They're putting solar panels on the roof, so you'll hear some clomping up there. It makes this whole thing shake too. All right, we're ready? See the answer? Ready? There you go. Raise your hand if you got it right. Good. See how many hands are up? That's a good thing. You guys are learning. Okay. I always have a moment of reflection as I teach because think all the stuff you've already learned today. Right? We've been at it for I don't know how long, half hour or something, 45 minutes. And you've already learned all this. It's kind of crazy, right? So you think about every single lesson I teach like this, you're going to learn a ton this year. So really important that in this first lesson you build some flashcards, right? So what flashcards might you make for what I've done so far? Who's got an example of a flashcard you might make? Right? That thing right there. That's a good flashcard, right? Maybe you do this as a flashcard, right? I might say this whole double the denominator concept, right? Because if I know that and I memorize that, it makes all those problems so much easier, right? And then in chapter 5, you're going to build a little deck of flashcards. You might have 20 flashcards, okay? And then when we get to chapter 6, you're going to keep those chapter 5 flashcards in that deck, and you're going to study all of them together, right? And if you do that for the 5 chapters we cover this semester, it's weird because one chapter, it's 3 chapters, pieces of 3 chapters. And the reason I do that is to follow the sequence of this crazy textbook. I'll show you the textbook. We use this curriculum instead. It's 1,100 pages long. The problem homework sets are 150 problems long. And I'm not using it. This is better. But if you build those decks of flashcards for each chapter that we cover and you study them along the way, when you get to the final exam, it is so much easier, right? Because you have all that stuff in your long-term memory. That's how you get it from short-term to long-term memory, by studying those flashcards. And then when you get to calculus next year in college, then you'll have all that stuff memorized. I would still even study them over the summer. What a concept, I know. Because in college, they expect you to remember everything they teach. And the final exams are comprehensive. And then me, when I was in grad school, I have 3 years of school. And I had to remember all 3 years of school. And take a test that was 4 hours long. And I typed 22 pages in 4 hours. Right? And I remembered 3 years of school. And I had a deck of flashcards that was that tall. Right? So that's the kind of stuff you have to start doing, unless you're just an insane genius. But there's not many people out there that are, so,
Nico and Levi.
Okay. So, what do I have to multiply this by to get a coterminal angle? What do I have to double? The bottom, right? So I add 24 pi over what? 12. And then I go pi over 12. I didn't mean to write this in hot pink, but, I try. Minus 24 pi over 12. Isn't that so much easier if you just think about doubling the denominator, right? Because that just wrecks people for a while. And I'm like, don't. It's easy. What's the answer to the top one? $25 pi over 12. Because that's not a problem where you see 25 pi over 12 and you're like, yay, I know I got it right. Right? Because 25 over 12? I don't know. It's weird. What do we get for the bottom one? Negative 23 pi over 12. So let's do, what do you want, 27 or 28? You choose. Doesn't matter to me. 27 it is. Do 27 on your own. I'll write the answers. You can double check in a minute. Levi was out of the room when we did that, so you missed it.
Yeah, probably why I'm not going to get it.
You will get it. Shut up. Okay. You double it, you're going to add and subtract 12 pi over 6, right? That's why you guys are happy you got this in the third year of me teaching pre-calc, because I got all the little tricks down. First year is a little rough. I'd be in here sweating, like hoping the smart kid doesn't ask the question, because you're like, I don't know. I studied hard though, I knew a lot of it, but sometimes I'll get stumped. It's okay, I'm not perfect. You ready for the answer? You good? Sweet. All right, moving on, next page. 19 pi over 6 and negative 5 pi over 6.
What? I did it.
Okay, now we got new concept, degree, minute, second form.
Last page, right?
DMS, you got 2 pages. Nice try. It's a good effort. Okay, so 1 degree is 60 minutes. 1 minute is 60 seconds. You know that just because you know it. Symbol for degree is a tiny little circle. Symbol for minutes is like the little apostrophe, right? Second is like the double. Okay? And I wrote them up top because you would have like a number there, right? So, we're going to follow the example below to convert 31.875 to degree, minute, second form. Okay? So, we start with the decimal portion, 0.875. Okay, we're going to multiply that by 60. When we do that, you can do that in your calculator, right? It's like 87% of 60. So if you think of that, right, is it going to be in the 50s? 87% of 60?
Yes.
Sure is. 52.5.
Well, that's what I guessed.
You're a genius. Okay, and then we're going to take that 0.5, right? So first thing I did is take the 0.875. See why highlighters are nice too? Like if you have highlighters, you use multiple colors and highlighters and you're going to know what the hell's going on. It's so nice. Right? Because it draws your eye to the part that you need. So now we take that 0.5. Right? And I'm going to highlight that again because that's where the 0.5 came from, the second row, first row up, down to the second. And then what do you think I multiply by? 60. And half of 60 is what? 30. Okay, so if I write this in degree, minute, second form, what degrees is it? The whole number of degrees? 31 degrees. What symbol do I need? Circle. Now here's the weird part. I'm going to write this in my hot pink annoying color. Actually, it's not technically round. Do you guys in chemistry, you learned, Shoop used to be big on this, but Shoop was he here last year? No. So truncate, did you learn about truncate? Means you just cut the decimal off, truncate. Okay, so we take that 0.5 and cut it off for the minutes. So we only use this part of it, the 52. I'll show you what I mean. So it's like this. Because we took that 0.5 and did the translation for seconds down here. So this row is what? Minutes or seconds? And this row is seconds, okay? So if you need to write that as well, because you're like, what the hell's going on? Because this is weird, right? So that was minutes up top, and this is seconds down here. So what should I put after the 52 minutes? 30 what? 30 seconds, double. Okay? So it's weird, right? You've never done something like that before. So again, you know how you get smarter? You learn new things. It makes you smarter. Yep. Because we dealt with the decimal right here, right? So that's why you take it off, because you got to change the leftover part, 2 seconds. So that's why you always take that off. Okay? Let's do one more together, and then I'll have you do one on your own. Okay? So we're looking at number 1 here. What do I have to do first?
Chop it.
0.48, what? Times 60. What are we talking about here? Minutes or seconds? Minutes. So I'm just going to write min in front of it so I can remember. And 48% of 60, 28.8. Again, you're going to be doing all that crap in your calculator. What's the next row down? Minutes or seconds? Seconds. What do I take? 0.8 times what? 60. 80% of 60, 48. Now we got to write the whole damn thing, right? What comes first? 15 what? Degrees. What's next? 28 what? Minutes. And then 48 seconds. So they use that, I think in like navigation they use that. Okay? So what's good about this curriculum, it's perfect for regular pre-calculus, right? And we will do application problems. But what will irritate you guys about pre-calculus is you learn a lot of like discrete skills, meaning like separate skills. And it'll irritate you at some point in the year, I guarantee it. You'll be like, "Oh my God, we're doing vectors now? Like what the hell?" And it'll make you mad, right? But you take all of it's called pre-calculus, right? So I'm getting you ready for calculus. So that's why you're going to build those decks of flashcards so you get that stuff in your long-term memory. Because if you study this class and you study your notes over this summer, your senior summer or your senior year, for those of you juniors in here, right, you'll be ready for calculus. Because Cunningham's pre-calc Calc AB packet is 22 pages long. Right? So I had pre-calc students, juniors from last year, this year seniors, that are in Calc AB coming in for help because they didn't remember all of pre-calc, right? So it makes sense that you wouldn't remember it all. All right, oh yeah, look at number 2. That's a good one to do because it's weird. So what do we do first? 0.2 times 60. What's 20% of 60? Anybody know? 12, good. How'd you do it so fast? It's good. Oh, you've been doing them? Okay. So what's 10% of 60? 6. You just move the decimal 1 over, right? If I want 20% of 60, what do I do with 6? Double it, right? Easy. So if you're tipping, high school kids are notoriously terrible tippers, right? I used to work in a restaurant. I know. I've seen you punks come into a restaurant and I'm like, oh God. Try to give it to my buddy so I can get stiffed on the tip, right? 20%, your bill's, let's say $32. What's a 20% tip? 10% is $3.20, $6.40, right? So it's easy to do a 20% tip, just saying. Okay, what did we just do right there? Minutes or seconds? Is there anything left over? Do I need to do seconds? No. So you can just write 150 degrees and 12 minutes, like that. Okay? Do number 5 on your own. I'll write the answer down here. Practice, practice. I'll show you the steps as well once I'm done up here. You should get some weird rounding at the end where you're going to be like, I'm not sure what to do. So if you feel that way, it's okay. I'm going to tell you. And always a good idea to like take a guess what you should do because you end up with a decimal at the very last step. What do you think you should do?
Round.
Which way?
Oh.
Ding, ding. Good job. Round up. Okay. So if you get a decimal at the end, you round like you normally round. Okay? Round like normal. So if you round like normal makes more sense to you than round up, right? Round like normal, right? In your different color, because it'll help you. Okay. Now we're going the other way. Okay? So the previous problems we went... Oh, hold on, I forgot to write that. That's fine. Okay. That's weird. Had a moment. It's all good. Okay.
That's a team boy right there.
So now we're going from degree, minute, second form back to just degrees. Right? So degree, minute, second, 2 degrees. It says it right here, right? Just so you know. That's kind of handy. So, this symbol right here means divide, yeah? What should I divide by?
60.
We take that 9 first, we divide by 60. 9 divided by 60 is 0.15. Now what do I do in the next row down? What do I put there? Because we're going the other way now. Because we already dealt with the 9, right? 50, very good. And I divide by 60 again. Right, 50 divided by, oh no, you don't do that. You do divided by 60 times 60, so 3,600. My bad. Because what's 60 times 60?
I'll roast that.
3,600. Are you going to cry? I got tissues up here if you need to wipe the tears. Cross it out, right? 3,600. My bad. Because we were dividing twice, right? We're dividing by 60 times 60. So if that does it, you're like, duh, that does not sink in, then just memorize that and say, first one 60, second one 3,600, right? And then you could go back the other way and it'll make more sense. And it's just effed up, right? That's the way it goes. 0.0139 is what you should have got right there. So now what we're going to do to figure this all out is we're going to add 73 plus, what do you think? 0.15 plus 0.0139. So it's weirder to go this direction, right? So you got to divide by 60 first and 3,600 second. And are you ever going to use this in your life? No, but get over it. Whatever. It's going to be okay, right? And if that makes you mad, when are we ever going to use this, then maybe you're in the wrong class, right? Because you're going to feel that way several times in pre-calc. So it's okay. You're allowed to feel that way. I didn't mean to leave a weird little gap there, but I'm rolling with it. Yep. Right? So we're just adding these two together. That's how we got that over here. Right? Add it up. So if we do number 9 here, we do 37 plus 36 divided by what? 60. Now you can put that whole damn thing in your calculator. I'll show you in a second. 37 plus 36 over 60. But I want to give you a chance to write that down. 37 plus 36 over 60. So when you put it in your graphing calculator, just put 36 over 60 in parentheses. So it was 37, right? Yes. Plus parenthesis 36 divided by 60. Close parentheses. 37.6. Okay? It's easier to do it like that, yeah? 37.6. Do 10 on your own. Number 10. I'll write the answer up here and you can double check once you're there. How many points would I lose? Half point, right? What'd I forget? Degree symbol. Don't forget that. I wrote it after the fact. I saw I forgot it and then wrote it. You can double check your answer.
Yes.
Right, you can write 0.13. I just wanted you to see that it repeats. The 3's go forever, right? It's all good. Let's do 11 and then we're done. Do 11, then we're done. 84 plus 52 over 60. And I'll plug that whole damn thing in your calculator. Plus 18 over 3600. So first denominator 60, second denominator 3600, right? How many people already have that memorized? There should be way more hands than that, just saying. Yeah, that's good.
Oh,
Okay.
I know. What?
And I'll tell you what you get. I would plug it in your calculator. Make sure you know how to plug it in your calculator because people do weird stuff. I'm going to round on this one. We'll round to thousandths. How many decimal places is thousandths?
3.
3. A lot of times in pre-calc we'll go to 4 decimal places. I'm just randomly choosing 3. So depends what we're doing, kind of. Oops. Rounded wrong. Right, because a 6 makes a 1 go to a 2. I just rounded because there was 6 repeating at the end there. Are you okay? Here, let me do it. It's been a couple years since I've done it. So 84 plus. Anyone remember what your homework was? 1 through 18 all, isn't that what it was? I think so. Okay, so that 6 repeating over there makes that 1 go to a 2. Right, you got to round the 1 up because of the 6. So we're going to the 3rd decimal place.
Wait, what are those last two numbers?
So that 6 makes that 1 go to a 2 if I'm rounding to thousandths. If I rounded to 10 thousandths, which is this spot, it would be 84.717. I'll tell you, always. Yeah, if I care, I'll tell you. Do it all at the same time, just like that, right? With the 2 fractions, and then because if you round in the middle, your answer gets more and more wrong as you go, right?